Hey pre-calc students, welcome to today's lesson on converting equations of hyperbolas to standard form. As you can tell, I'm coming to you live from mi casa because I barely have a voice and I had to record myself teaching you this lesson instead of being in person. I also cannot breathe through my nose. Hee hee, super salad. But I'll see you soon, okay? All right, so bear with me in this crazy voice. I know it sounds like my nose is plugged because it is. All right, so let's start with a review of what we did yesterday. Okay, just graph and identify the specified parts of the hyperbola. All right, so the first thing that I'm going to do is I'm going to identify the center. So remember that the center is an ordered pair. It has to be in alphabetical order. The x value has to be written first and then the y value. So be careful because they actually gave you the major axis first, which is the y-axis, but make sure you put that as the y value of the center, okay? So the center is not -6, -3, it's actually -3, -6. So the minor axis is the x-axis, okay? Okay, so now that we decided that the major axis is the y-axis, that means that our hyperbola is going to be a vertical hyperbola, so it's going to open up, one parabola is going to open up and one's going to open down. Okay, so for the vertices on my y value of my center, I am going to go plus or minus 2 because the square root of 4 is 2. That's vertices represent the letter D, and then E is the covertices. The square root of 25 is 5. So that affects the x-axis. That's the minor axis. So that's what you're going to change the x values by of the center. Okay, so -3, -6 is over here. That's the center. Then I'm going to go 2 spaces up and 2 spaces down. Remember, those are your vertices. So that's -3, -4, and -3, -8. Okay, I'm also from the center going to go 5 units left and right. Those are my covertices. So you should land at -8, -6, and 2, -6. Okay, so this is enough for you to draw your little rectangle. And remember, we need the rectangle so that we can connect the corners that are opposite from each other, okay, to draw our vertical asymptote. So now I'm going to connect these two with a dashed line, and I'm going to connect these two with a dashed line. So remember, we already decided that this hyperbola opens up and down. So half of it opens up, half of it opens down. So we're going to use the vertices. Those are the ones that I have in orange. And you're going to use the asymptotes to kind of help you, oopsies, to draw your two parabolas, okay? So remember to try to make them look like they're getting closer to the asymptote. You do not need the foci to graph the hyperbola. As you can see, I already graphed it, but they are asking me to find the coordinates of the foci. Remember, you need to use a formula for that. C squared equals d squared plus e squared. So if I fill in my values for d squared and e squared, I find that c is a plus or minus square root of 29. So remember that the vertices and the foci are both involved with the major axis. In this case, it's the y value of, it's the y-axis. So you're going to add and subtract square root of 9 to the y value of the center. So the x value doesn't change. You're going to add square root of 29 and subtract square root of 29 to the y value of the center because the y was the major axis. Okay, so the asymptotes, you're going to write out a point slope form. So this is kind of like the setup. Remember that you're going to use the y value and the x value of the center. So that's negative 6 and negative 3. But remember, I don't want you to leave double negatives in your answer, so these should get switched to plus. And then the slope of the diagonal is up to over 5. Remember, it's rise over run, and we put plus or minus because one of the diagonals has a positive slope and the other one has a negative. So that's why you put plus or minus. Remember that when you're watching these videos, you can pause, rewind, rewatch anything that you need that you missed, okay? YouTube even lets you slow down the speed. Okay, so that's just a review of what we did yesterday. Let's take a look at what's new for today. So for today, we're being asked to write the equation in standard form and graph it. So as you look at this equation, you should notice that both quadratic terms exist, right? The quadratic for the x's and the quadratic for the y's, but they have opposite signs. So that means that this is a hyperbola, not an ellipse or a circle. So the first thing that you always want to do anytime you're completing the square, which is the strategy we used for circles and ellipses, is move the constant term to the other side. But if you look, the 41 is already on the other side. The next thing you want to do is the standard form of hyperbola should have your positive variable written first, your positive quadratic. So I'm going to start gathering the terms, but putting the y squared first and all the y terms together at the beginning because we want to put the positive quadratic term first, okay? So in this case, it's the y values. I'm going to go ahead and leave a space for completing the square. Um, you could do it now or you could do it later. I'm going to do it right now. Then I'm going to write all the x terms, leave a space, and then here's the 41. Okay, so technically I can start completing the square now. So for this guy right here, the y values, you take half of 4 and square it, right? So what's half of 4? 2, and then 2 squared is 4. Don't forget you also will need to balance that on the other side. However, this guy, I'm not ready to complete the square for, okay? So I need to make sure that I divide this by negative 9. So I'm going to write what it originally was. Okay, and I'm going to factor out the negative 9. You're not factoring out a GCF. Remember, you're just factoring out the coefficient. You cannot complete the square until you factor out the leading coefficient so that it becomes a 1. So I'm going to have x squared. Now remember, we're dividing by negative 9. Negative 9, negative 9. And 36x divided by negative 9 is negative 4x. Now I can complete the square. So the b value is negative 4. So half of negative 4 is negative 2. And negative 2 squared is positive 4. So that means I also need to, oopsies, not 4. Oh, Lord of Jesus, I almost messed up. It's not really a positive 4. It's negative 9 times 4. So that's a negative 36. Whew, that was a close one. Okay, so if I factor these trinomials, I'm going to have y plus 2 quantity squared minus 9 and x minus 2 quantity squared equals 41 plus 4 is 45, and 45 minus 36 is 9. When it comes to hyperbolas, they have to equal 1. So my last step is to divide every single term by 9, okay? So I noticed on your quizzes that some of you only divided the first fraction by 9. You have to divide every single piece by 9, okay? So that's both the y plus 2 quantity squared that needs to be divided by 9 and the negative 9x minus 2 quantity squared. So all you do now is reduce, reduce, reduce. That's going to give you a final answer of y plus 2 quantity squared over 9 minus x minus 2 quantity squared over 1 equals 1. Okay, so the center of this hyperbola is negative 2, 2. The major axis is the y-axis because that's the one that didn't have the subtraction in front of it, right? The subtraction is in front of the x minus 2 quantity squared. So the axis is the minor axis. Go ahead and pause the video right now and see if you can graph this by yourself. Push play when you're ready. Oh my goodness, I just realized I wrote the center wrong. I always tell you guys to be careful with stuff and I have to mind my own advice. So the center is 2, negative 2. Remember, because the x has to go first and then the y. So if you caught that A plus to you for the day, it is 2, negative 2. Okay, so 2, negative 2, whoopsies, is here. Then I'm going to go up 3 and down 3 vertically for the major axis of y, and I'm going to go right 1, left 1. So I have a really skinny little rectangle, and then when I connect opposite corners, oops, that started getting crooked real quick. I strongly recommend you guys use your like ID or driver's license if you can. Okay, and remember this is a vertical hyperbola, so it's got one of the parabolas opens up and one opens down. So how did you do? Did you catch my mistake for the center? Were you able to draw it opening up and down? Little by little, the more you practice, the easier the graphs will be. Okay, so here's another one that's written in standard form. Or sorry, we need to write it in standard form. So pay attention to which variable is positive in terms of the quadratics. Is it the x squared or the y squared? If it's the x squared, then you want to write that one in front. So notice in the previous problem, the y squared was positive. So we moved all the y terms to the front. So in this case, it's the x squared. So I'm going to move all the terms with x to the front. And it looks like they kind of already are. Notice also my constant term is not on the other side yet. So I'm going to go ahead and move that over. I'm going to leave a space to complete the square. And actually, I just want to show you because I don't know if I explained it very well the first time. You are not really ready to complete the square for the y's. You're going to need to divide by negative 4 because your leading coefficient must be a 1 in order for you to complete the square. So now you should be able to complete the square. So 8 divided by negative 4 is negative 2. All right, so to complete the square for this first trinomial, you're going to take half of 2 and square it. So half of 2 is 1, and 1 squared is 1. For here, you're going to have to take half of negative 2. Remember, we got that from dividing 8 by negative 4, which was the leading coefficient. That's also going to be a positive 1. Right? Half of negative 2 is negative 1. Negative 1 quantity squared is 1. Don't forget the balance. So we've added a 1. So I got to do the same thing here. A negative 4 times 1 is negative 4. So I have to include that as well. Okay. So don't forget the balance. Balance. Okay, so now I'm just going to factor. So this is x plus 1 quantity squared. Watch your signs. Whatever half of b, that's what goes in the factored form. Whatever half of b is, right? So here I have the -4, and then half of -2 is -1. And then remember that for ellipses, you need to have it equal 1. So I'm going to go ahead and divide everything by 16. So now you just reduce, 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 reduce. So x plus 1 quantity squared over 16. -4 divided by 16 reduces to -1/4. So I'm not going to put the 1, but you're more than welcome to do so. Okay, so now I want you to pause the video. I'm going to make sure I write the center correctly. So this time the x is written first. So -1, comma 1. Major axis is the x-axis. Go ahead and pause the video and see if you can graph this by yourself, and then push play when you are ready. Okay, so center is in quadrant 2. I'm going to go 4 units left and right, which is my major axis. I'm also going to do 2 units up and down. This will help me draw my rectangle. Connect the diagonals. Now remember, the major axis was the x-axis. The x-axis goes left and right, so your two parabolas, you should have one opening to the left and the other one opening to the right. And it has to pass through the vertex. This one I kind of missed it by just a little bit. There we go. Okay. All right, kids, as always, if you need help, feel free to text me or go into the Math Resource Center for extra help. I hope you have a great day. Adios.